Hey, have you ever really stopped to think about how a program actually makes a decision? How it knows to do this instead of that. Well, today we're going to pull back the curtain on that very magic. It's the simple, powerful logic that runs pretty much everything.
I mean, seriously, think about it. How does a video game know you just crushed the high score? Or how does a website know you typed in the right password? It's not magic, right? It all comes down to asking a very simple question.
And the best way to picture this is to imagine that your code hires its own bouncer. Yep, a digital bouncer standing at a velvet rope, checking IDs, and making sure something meets the criteria before it's allowed to come inside. This digital bouncer is really the heart of your program's brain. Its job is to constantly ask these little yes or no questions to figure out what happens next. Stuff like, is this number bigger than that number? Or do these two words match? Super simple questions, but they are incredibly powerful. So what tools does our bouncer actually use to ask these questions? Well, it has a very specific toolkit, a set of 6 symbols that we call comparison operators. Let's get to know them. And what's amazing is how simple these really are. The double equal sign, that's just asking, hey, are these two things exactly the same? The exclamation point with the equals, that's asking, are these two things different? And then you've got your classics, greater than, less than, and their cousins, greater than or equal to, and less than or equal to. That's it. These 6 little symbols are the foundation for every decision a program can make. And that's their official name, comparison operators. All they are symbols that let you compare one thing to another. It's really that simple. Okay, before we go another step, we have to talk about this. This is probably the #1 thing that trips up new programmers. The single equal sign versus the double equal sign. They look almost the same, but they do completely opposite jobs.
So here's the absolute key difference. A single equal sign is a command. It's you, the programmer, telling the computer, hey, make this variable x hold the number 5. But a double equal sign, that's a question. It's you asking the computer, hey, just wondering, does the variable x currently hold the number 5? One is an order, the other is a question. Huge difference.
Now, here's the really beautiful part. No matter what kind of question our digital bouncer asks with its operators, it can only ever give one of 2 answers. That's it, just 2. In programming, we have a special name for these answers, Booleans. It sounds kind of fancy, but it just means a value that can only ever be one of 2 things, true or false. There's no maybe, no kind of. It's a world of black and white, yes or no. All right, let's put our bouncer to the test. Here's its first job. Check if 100 is greater than 99. So what do you think? What's the bouncer going to say? Is it a yes or a no? What's the one and only possible answer here? You got it. True, of course. 100 is greater than 99. The bouncer checks the ID. It's valid. The verdict is true. Okay, let's try one that's a bit more practical. The required age to get past that velvet rope is 21. Our customer is 20. So the bouncer runs the check. Is the customer's age greater than or equal to the required age? So what's the call? Based on that comparison, customer age greater than required age? Does this person get into the club? Nope. False. 20 is not greater than or equal to 21. The bouncer's verdict is crystal clear. Sorry, not tonight. Okay, so this is great. We can get a true or a false verdict. But, so what? How does the program actually act on that verdict? Well, that's where the if statement comes into play. This is how we turn that simple answer into a real action. It's really just a simple 3-step dance. First, the if statement asks the question. Second, our bouncer gives the verdict, true or false. And third, and this is the most important part, only if the verdict is true does the program run the next chunk of code. If the answer is false, it just skips right over it and moves on. And look at this. This brings us right back to our original question. The code asks, if the player's score is greater than the high score, what's the verdict? Well, 12,500 is bigger than 10,000, so the verdict is true. And because it's true, the program is allowed to run that print command, and congratulations pops up on the screen. Simple as that. And just like that, you've totally grasped the core of how programs make decisions. Let's do a quick recap of what you've just wired into your coding brain. You now officially have the Bouncer's Complete Toolkit.
That's 6 core operators that give your code the power to compare anything and make a judgment call. So, to nail it down, the operators ask the questions. The answers are always Boolean, true or false. Remember, a single equals tells a value what to be. A double equals asks what it is. And finally, if statements are the action takers. They use those true or false verdicts to decide what to do next. You've basically just learned the entire foundation of how programs think. And seriously, don't underestimate what you just learned. This is not just some little Python trick. This idea, asking a question that gives you a true or a false, and then doing something based on that answer, this is the fundamental building block. It's the heartbeat of logic in pretty much every single programming language on the planet.
So that really just leaves us with one last question. You've given your code a brain. It can make choices, it can react, it can decide. What are you going to build with it first?